resistance, inductance, capacitors are in series. Now we are connected that capacitor, resistor and inductor separately with the AC circuit. So now we are going to connect all the three things with the AC circuit. Resistor, inductor and capacitor. All the three components are connected to the AC circuit. So what will be the output? So now we are going to see that resistor, inductor and the capacitors are connected in series. So see that now that AC circuit alternating source of EMF, we are connecting the resistance of the circuit and inductance, next capacitance of a capacitor. So all the three components are connected. Current I is flowing through the circuit. So according to Ohm's law, V is equal to IR is based with the I. So V equal to IR. So resistance connected means current and voltage are in the same phase. Suppose inductance is connected, that the voltage drop of the inducting coil is I into XL. So there is a phase difference. Voltage leads the current by the phase angle of pi by 2. Suppose capacitor is connected, so V is equal to I into R. R is XC, that is capacitive reactance. Now current leads the voltage by the phase angle of pi by 2. So you can get the graph like this. So VL, VC and I. So here VL and VC is in the opposite direction. So you can take any one is dominating. Now we can consider that inductance is dominating the capacitor. That's why the blue color line in the upward direction. Okay, predominantly inductive. So dominate பண்றதா வச்சுக்கிட்டோம் அப்படினா we can get the graph like this. So OB is the resultant potential B and VR is the resistance, VL is the inductance and VC is the capacitance sort of value. So see here, so in this triangle OB, that is the resultant, we have to calculate that this one is VL and VC. இது capacitor, inductor ரெண்டுமே ஈக்குவலாக தான் இருக்கும் ஆப்போசிட்ல இருந்தா. அப்படி இருந்தா நமக்கு வேல்யூ கிடைக்காது. அதனால நம்மளாவே என்ன சொல்றோம் அப்படின்னா VL, that is inductance, is predominantly dominating the capacitance. We are considering that inductance value is a higher value compared to the capacitance. Capacitance விட inductance value அதிகமா இருக்கிறத நம்ம எடுத்துக்குவோம். அதனால இங்க மேல லைன் போட்டுருக்கோம். அப்போ இது ரிசல்டன்ட் OB அப்படின்னா you can consider the triangle OBA, this triangle. So we need the value of OB. So what you have to do? OA square plus AB square. So we are writing like here. So OB square, that is OB square is the resultant potential B square. OA is the resistance, connected resistance, that is the line indicates the resistance. So VR square. Then AB is the VL minus VC. So total is VL. Up to this we connected the VC. So this is the distance, that is VL minus VC. So substituting here. So that is V square equal to, suppose we need that V, we have to take the square root. So inside the square root we are writing like this and substituting that values. V equal to IR according to Ohm's law. So V equal to I into R. VL equal to IR. Here XL is the resistance, nothing but XL is nothing but resistance, that is inductive resistance, reactance. So inductive reactance, that is nothing but resistance. I into XL. And VC, I into R. I into R, this is called capacitive reactance. This is capacitor resistance. That's called capacitive reactance. So I into XC. Right? So I is common. So we can take it out outside. So R square plus XL minus XC is the whole square. Now the next step, V is here. So V by I. So V by I equal to R. That is according to Ohm's law. V by I equal to R. Instead of R here we are writing that Z. Z means that is called impedance. That letter Z is called impedance of the circuit, which refers to the effective opposition to the circuit current by the series RLC circuit. Okay, right. So that is a circuit Z. So see that again once. So it's very important. depending on the phase difference between the resistance, capacitor and inductance, we are derived that equation. Okay, so it's very important equation, important 5-mark question. Now impedance diagram, the expression R square plus XL minus XC the whole square is the net effective opposition offered by the combination of resistor, inductor and capacitor, known as the impedance of the circuit, and is represented by the Z. So XL minus XC, or you can write a VL minus VC. So it's called the impedance diagram. So only triangle is in your book. So it's called the impedance diagram. Next thing, the phase angle pi between the voltage and current is given by tan pi equal to, we are taking that angle, this angle is pi. So tan pi equal to opposite side by adjacent side. So VL minus VC divided by PR. So VL equal to, we know the value I into R, V equal to IR XL according to Ohm's law, I into XL, I into XC, IR. So I is common, so I is cancelled in numerator and denominator. So tan pi equal to XL minus XC by R, that is equal to net reactance divided by resistance. Or you can write tan pi equal to tan inverse of XL minus XC by R. So the final current I equal to I0 sin omega t plus or minus pi is the instantaneous current flowing through the circuit. Why we put plus or minus means, suppose that XL, that is inductive reactance, is dominating. So what will happen? Inductive means that current lags behind. So you will put minus sign here. Suppose capacitor is connected with the circuit, the current leads the voltage. So you have to put plus pi. So that's why we are writing here plus or minus, right? So XL greater means minus, XC greater means negative. So here, depending on that at any sort of time, that current will flow through the circuit. So that will shown in the picture. So XL minus XC positive, that means its applied voltage leads the current. XL minus XC is negative, therefore current leads the voltage by the First law of pi. So suppose there is 0, XL is equal to XC, ரெண்டுமே ஈக்குவலா இருந்தது அப்படினா that is become 0. Therefore current and voltage are in the same phase in the circuit. Is resistive. Resistance மட்டும் இருக்கிற மாதிரி XL equal to XC னா ரெண்டுமே காலி ஆயிரும். They cancel each other. So it has only the resistance. Okay. So that is the phase between the two things.